Welcome to the 5-2 video geometry for perpendicular and angle bisectors. Students will be able to use properties of perpendicular bisectors and angle bisectors. Should be a rather quick video, just going through a couple different theorems that happen when angles or sides get cut in half and what happens with that. So, perpendicular bisectors, those are lines, segments, or rays that cut a segment in half at 90 degrees at its midpoint. So it's perpendicular through the midpoint. Okay? So a good picture of that, a segment, a line, or a ray. Let's do it this way actually. So we'll have a segment that's getting cut in half. If we know what the midpoint of that line is, if a line is cutting through that at 90 degrees, this is called a perpendicular bisector. Okay? Being equidistant, what that means, just some vocab to get started. Equidistants are two things that are the same distance. Okay? This word literally means equal distance. Okay, so if you see the word equidistant, you got to think of two segments or two vertices that are the same distance from something. Okay, the distance from a point to a line. All right, the length of the perpendicular segment from the point to the line. So here's my point. Here's my line. All right, you may have heard this. The fastest way to get in between 2 points is always a straight line. The distance from this dot to the line below it is the perpendicular distance directly to that line. Okay, so the shortest distance between any 2 points is a straight line, and here we're adding the word perpendicular as well. Okay, if a point, so here's theorem 5-2, perpendicular bisector theorem. If a point is on the perpendicular bisector, so you have a perpendicular bisector in the picture. If you are on that, then that point, the point P this time, this point P is on the perpendicular bisector. The line PM is cutting AB in half at 90 degrees. Okay, that means it is equidistant from the endpoints. So let me show you what that means. Since point P is on this line, that's a perpendicular bisector, okay? What I know is from P to B, that is the same distance as P to A, guaranteed, okay? So that's what's happening in this picture. These two are marked congruent, okay? Since the point P is equidistant from B and A, okay? This works backwards, so there's a converse to it. All right, so if I were to highlight again, I'd be highlighting the same phrases, but in the reverse order. Okay, if a point is equidistant from the endpoints, okay, of a segment, the only way that happens if it is on the perpendicular bisector. All right, so if you see something looking like a triangle, this point P is the same distance from A as it is B. What that means is, if I drew a line through P, the perpendicular bisector, P would be on that perpendicular bisector going through that triangle. Okay? So it works forwards and backwards. It's something you can make a biconditional of. Okay? So using it, this will be the type of question you might see. It says, what is the length of AB? Well, here's what I noticed right away. I see a perpendicular bisector. This BD is perpendicular to AC, and it's cutting it in half. So that makes D the midpoint, okay? Which means that we can use the perpendicular bisector theorem to figure out the length of AB. What I know then, B is a point that is on that blue line. That means the distance from B to A has to equal the distance from B to C. So AB has to equal BC. Those should be equidistant. Okay, that would be our perpendicular bisector theorem. What that means using substitution, AB is 4x BC is 6x minus 10, and then I can solve this for x. I can subtract both sides by 6x, giving me negative 2x equal to negative 10, dividing by negative 2, giving me x equaling positive 5. Okay, we did not answer the question. They want the length of AB, so we're going to take that x equals 5 and plug in for our final answer. AB is 4 times x, and we just figured out that x is 5, which means that AB is 20. If I plug in 5 to the other equation, I should get 20 out as well. So that would be 6 times 5, or 30. 30 minus 10 being 20. Okay, we can try that again here. Okay, the length of QR. Again, same setup. QS is a perpendicular bisector of PR. And since Q is on that perpendicular bisector QS, that means it's the same distance from P as it is from R. All right, so the first thing I would know is that PQ has to equal RQ. All right, by the perpendicular bisector theorem. All right, which means 3n minus 1 has to equal 5n minus 7, which means I can solve this for n. So I can get all the n's on the same side. I can get all the numbers on the same side. Be careful when you do negative 1 plus 7 to get positive 6. That means that 6 is equal to 2n, dividing both sides by 2. N is 3. We're going to answer the question now. They want the length of QR, which is 5 times n minus 7. So QR equals 5 times 3 minus 7, since we decided that n was 3, which means we have 15 minus 7, or a total of 8 for QR. If we plug into the other one, we get 3 times 3, or 9 minus 1, which is also 8. Okay, that's kind of the first half of the lesson today. That's perpendicular bisectors. The next part is angle bisectors. All right. So the angle bisector theorem says, very similarly to the perpendicular bisector theorem, if a point is on the bisector of an angle, so instead of being on a perpendicular bisector, being on an angle bisector, very similar conclusion. That point is equidistant from the sides of the angle. Okay? And it works backwards, and I'll scroll back up in a second to explain. All right, if a point is on the interior of an angle is equidistant from the sides, if you see a point that's equidistant from the sides, that means it is on the angle bisector. Okay, so let me explain what that is saying, both the angle bisector theorem and its converse. If you see that this point S is on an angle bisector, okay, so we see down here the angles are marked as congruent, S, then, is equidistant from the sides of the angle, meaning the distance between S and P should equal the distance between S and R. Okay? And vice versa, if we see this situation, S, which is equidistant from the sides, remember the distance between S and the sides of the angle is the perpendicular distance. That's what we mean by distance. If that's true, that means if I draw this line in, this ray I should call it, that would definitely be the angle bisector. Okay, so looking at problems related to that, it's going to be very similar. What is the length of RM? So that's the question we got to remember to answer. I see RM right here. Okay, that's what they're asking for the length of. RM and RP should be equal to each other, because R is on a ray that is cutting the entire angle in half, meaning NR, ray NR, is an angle bisector. So since NR is a bisector, that means RM has to equal RP, which means 7x has to equal 2x plus 25. All right, I can subtract both sides by 2x, and then divide both sides by 5, and get my answer x equals 5. All right, but with that answer, I need to plug in and get the length of RM, since that was the question. 7 times, we found that x was 5, or RM is 35. Okay, checking our work. If x is really 5, then we would have 2 times 5, or 10 up top. 10 plus 25, still giving us that 35. Okay, last one. What is the length of FB? All right, FB is here. It should be equal to FD because F is on the angle bisector of angle C. Okay, which means FB is equal to FD, giving us the ability to say that 6x plus 3 equals 4x plus 9. I can subtract both sides by 4x. I can subtract both sides by 3. I get 2x equal to 6, or x equal to 3. All right, and I need to take that and figure out the answer for FB, which is 6 times 3 plus 3, or 18 plus 3, or FB is 21. Always a good idea to check, make sure we got the correct x value. If I plug 3 into FD, I get 4 times 3, or 12. 12 plus 9 is also 21, so that works. Okay. So with perpendicular bisectors or angle bisectors, what happens is you have equidistant points from anything on that bisector. So that's kind of the gist of it. A lot of setting things equal. Go ahead and give the worksheet a try.